Society is moving fast towards a digital world. Everything from our phones to automobiles and infrastructure are witnessing the implementation of data and AI. How fast are we moving in this technologically advanced world? Fast, not fast, or maybe too slow? These are the differing opinions of the billion people that reside on Earth. Space technology and sciences have seen major advancements, and the investments seem to grow every year. More so are its diverse applications in the real world. In the recent past, 3D printing has created a wealth of opportunities for advancements in healthcare and engineering. While many of us are still to grasp this unique innovation along with new applications and ideas, another printing idea is on its way. Any ideas as to what it is? You guessed it right. But before we reveal this new technology, how does one even add the extra dimension to it? 4D printing technology is a part of the ongoing developments at the MIT Self-Assembly Lab. This work takes into account a new dimension, the temporal. This means that the printed material, when ready, can be modified, transformed, and allowed to move independently based on given environmental stimuli. To put it in simple terms, the printout will perform actions and move in accordance with external factors like changes in temperature, force, lighting, etc. More like how we human beings function. If it gets too hot, we migrate our head to the beach. If it gets dark outside, we return home. Think of Newton's first law of motion. Here's an example straight from the MIT Self-Assembly Lab. In this video, we see a flat printed structure slowly change its form when placed in hot water. The concept was theorized by researcher Skylar Tibbits of the Faculty of Architecture at MIT in collaboration with Autodesk and Stratasys. While this technology is still new, its applications are said to be far-reaching, from automobile to construction to healthcare. Let's go into the technicality of this innovative technology. 4D basically has an extra D than 3D printing. 3D printing consists of repeating a 2D structure layer by layer, from the bottom all the way to the top, including a 3D volume by layer. 4D converts this with respect to an additional layer, time. As mentioned earlier, the printed material transitions to different forms as a response to an external stimulus. 4D printing makes use of smart materials such as single-shape polymers, liquid crystal elastomers, composites, hydrogels, and other multifunctional materials. Due to their thermomechanical and other technical aspects, these smart materials are given the attribute of shape change. This is what differentiates them from 3D printed products, which are characterized by rigidity. So how do these 4D devices respond to external changes in the environment? It's simple, or maybe not, depending on your familiarity with big data, AI, and machine learning. But to keep it simple, various algorithms are inserted during the 4D phase of printing the device. This geometric code allows for the shape-shifting nature of the product to adapt to sensitive artifacts and complex environmental factors. The codes are given based on the angle and dimensions calculated for the specific functions. The type memory and instructions on changing shape and moving to external stimuli are given at the same time. By integrating the time factor, the smart object changes its form without any electromechanical or moving parts, based on the requirements of the scenario. To get a visual sense of this information, let's look at an example provided by the Weiss Institute in Harvard University, which exemplifies this concept of shape-shifting architecture. 4D printing makes use of a modified 3D printer. The layering process mentioned earlier is used to create smart models which are designed to install additional designs automatically. The intelligent material used in this process is connected to plastic strands and also contains water. The water acts as a connective medium in which the intelligent material holds the water and stretches or changes shape while the model is being printed, thereby allowing it to bend or curl. When the printed model is produced, the water layer allows for shape configuration and elasticity. Finally, with the effective use of memory, the printed model can then change its shape based on environmental factors. So what's the advantage of 4D printing? Should we be anticipating something beyond our imagination? Size change. That is perhaps the most obvious answer we would expect. the ability to change shape over time. A simple answer which beckons potential. This potential refers to new materials, new technologies, and new ideas. A potential for a revolution of new, out-of-the-box applied materials that will disrupt the world of materials as you know it. Just imagine printing something more than just a printer or a robot. Think bigger, think better. Yes, it's a plethora, but only time will tell. 4D printing isn't just a practical innovation, but it is a better method of producing items and products. This is obviously true as it's a major step in the field of multi-dimensional printing. It can even minimize manufacturing labor costs. Products can be extensively printed in 3D and modified when exposed to the external surroundings. When the potential applications of 4D printing involve self-made furniture, manufacturing, defense, automobiles, and the medical industry, one can only imagine where we can go from here. We live in an ever-changing and learning atmosphere. Technology and data are at the forefront of our transitioning world. Think big. This is Technology Curious. Thanks for watching, and I'll catch you in the next video.